Deriving topological independence in vector calculus identities. This proof begins by establishing a target identity that connects standard vector calculus to index notation. To facilitate the derivation, a vector field is constructed using an arbitrary constant vector, which allows for the application of the Kelvin-Stokes theorem while isolating a specific scalar function. Through a series of mathematical transformations, certain terms are eliminated, and the remaining expression is translated into a framework using the Levi-Civita symbol and Einstein summation notation. Because the resulting equality must hold true for any arbitrary vector, the individual components within the expression are logically proven to be equal. This conclusion is validated through numerical demonstrations that compare line integrals around a boundary to surface integrals across various geometries, ranging from simple hemispheres to complex, rippled surfaces. Ultimately, the process confirms the principle of topological independence, proving that the theorem depends entirely on the boundary and is unaffected by the specific shape of the surface.